Hello, just a quick video to show you how to do part 1 of Text 6. So we need to open up the normal distributions application. So that is in your StatSims folder right here, normal distributions. I already have that open, so I'll pull that up. Make sure you always remember to put your name in so that it locks in the date and time. And this is going to pop up on the CDF tab, but we want to do identify for this one. And we have done this before. I just want to show you a new trick that we can do to try and get the standard deviation nailed down a little bit faster than we might have before. So we're trying to identify the red curve. The purple curve is the standard normal. That means it has a mean of 0 and a standard deviation of 1. We really needed that before in Chapter 3 to make comparisons. I would argue that we could just figure out the red one without this one to compare to this time, and I'm going to show you how I would do that. So we figured out before that the mean is wherever the peak is. So the peak seems to be right about there. That's to the left of -5 and to the right of -6, probably a little closer to -6. So I'm going to start out with a guess like -5.6 for that. And then for the standard deviation, what we did in Chapter 3 is we said things like, well, this curve is wider. The standard deviation does directly control how wide a curve is. So we looked at this and said it's wider than this one, and this one has a standard deviation of 1. If this has a bigger width, it must have a bigger standard deviation, and that approach would still work, but I want to show you another one instead. So I'm going to bring in the graphing calculator here and think about the fact that where the curve flattens out is about 3 standard deviations to the right of the mean and about 3 standard deviations to the left of the mean. So I'm going to go over here on the red curve and look at the part where like this white gap between the graph and the number line starts to disappear, and I'm going to try and make a guess at what that number is. And that looks like that's about in the middle of -1 and -2, so I'm going to guess -1.5 for that. So I'm going to turn on the calculator and I'm going to put in that right side, -1.5, and then I'm going to subtract whatever the mean is, and the mean was -5.6. I'm trying to figure out how far it is from the flattening out spot on the right to the peak in the middle, and when you're doing that, it's always right minus left to give you a distance, and so there's a subtraction here because we're trying to do distance, but then the mean itself is negative, so we need another subtraction there. Make sure you don't forget to do the subtraction for doing distance, and then if the mean is negative, you'll need another one. So when I calculate that, I get 4.1, so I just need to remember where a curve flattens out. It has its peak at mu, and then it flattens out at mu plus 3 sigma. So this distance from the peak to the edge should be about 3 standard deviations. So this 4.1 right here represents 3 standard deviations. So if I divide it by 3, that should just be 1 standard deviation. So I'm going to guess that the standard deviation is about 1.367. I'm going to enter that in, and then I'm going to click guess, and it did tell me too much error, but I have a nice close start right off the bat by using that technique. So my green curve looks like it's maybe a little bit too far to the right, so I'm going to go with -5.7 and see if that's an improvement. And then I got to start thinking again about the fact that the height isn't right. So my green curve looks too tall, but we have to remember that what the standard deviation directly controls is width. It only indirectly controls the height. So if I want this to be shorter, what I really need to think about with standard deviation is that I need it to be wider. And if I want the curve to be wider, I want it to have a bigger standard deviation. It looks like I missed by a fair bit there, so I'm going to try going to 1.467, just making that a pretty decent chunk bigger and see what happens. And then I got told nice job. So a pretty quick, decent first guess followed by an adjustment that got me the reward I was looking for, right? Told that the graph was acceptable. The peaks seem to be lining up pretty good. I'm just going to make some small adjustments here now just to, I don't know, show off or something. But I think the green one could stand to move a tiny bit back to the right, so I'll make the mean a little bit smaller. And then we could still stand to drop down a little bit too, so I'm going to make this a little bit bigger, which will make the curve wider and therefore a little bit shorter. So let's see how that does. So now those are almost overlapping. Okay, So that's how we can use the fact that the curve flattens out at mu plus 3 sigma to help us. Alright, let me go ahead and just show you one more of those to help you get the hang of it. So I'm going to click on New, get another curve. Looks like the peak is right about here. You know, in fact, I did one already that was on the left. Let me hit New a few times, see if I can get one on the right that's taller. There we go. So just so we're seeing a little bit of variety there. So the peak on this one seems to be right about here, which if I drop down, maybe that's around 1.3. So I'm going to put that in for the mean. And then for where the curve seems to be disappearing, its visible edge seems to be somewhere right about here. And that looks like that's happening pretty much at 4. So I'm going to do 4 minus 1.3. So I'm taking the right visible edge where the white is disappearing, subtracting the mean of 1.3. That gives 2.7. And that 2.7 is not the standard deviation, that's 3 standard deviations. This doesn't make sense as the standard deviation. If I put a 2.7 right here, that's bigger than 1. This curve would get much wider than the purple one and therefore a lot shorter. But this is 3 sigma, so if I divide the 3 out, I just get sigma, or the standard deviation, of 0.9. And I'll check that here in just a second, but I do want to say that it makes sense because this curve is taller and narrower than the purple one, and remember, standard deviation directly affects the width. So if I want this curve to be narrower than the purple one, I need the standard deviation to be smaller, and this is standard normal, has a standard deviation of 1. So 0.9 is a smaller standard deviation for the red, which should make it narrower, and that should make it taller. So let's see how that guess goes. On the first try we got told nice job, right? So that's the benefit of using the calculator here, and the idea that the curve flattens out at 3 standard deviations. And then I always just want to get a little greedy, so I'm going to see if I can make that fit a little bit better. I think moving the curve a tiny bit to the right would be helpful. And then I want the green to go up a little bit. That's what my eye always sees as height, but standard deviation doesn't directly affect the height, it indirectly affects the height. So if I want the curve to go up, what I really need it to do is become narrower, and that means a little bit of a smaller standard deviation. So let's try something like 8.7 and see what that does. That'll make the curve narrower, so it should make it taller. And that looks like a super good fit right there. I can still see a tiny little gap, so I'm going to make this 8.6. That'll make it a little bit narrower and a little bit taller. And now I can't really tell the difference between those two curves. And I could go ahead and do my screen capture. If you're using Alt Print Screen, remember that if the graph disappears, you can click refresh to get a new copy. Alright, good luck with this one.